Hello friends, welcome to our channel. Today we are going to start next part of the chapter, next part of the exercise 3.1. We have already discussed some concepts related to circle and we have solved exercise 3.1. Now today we are going to start the next part. Before starting the next exercise, we are going to discuss some points. This is a circle and this is an arc AB. The angle subtended by this this is a chord AB. Angle subtended by the chord AB at a point on the major arc. Let this is the point C, and angle subtended by the same chord at another point which is situated at the minor arc. So we are going to first write the relation between these two angles. If this is the center, okay, the angle subtended by the same chord, one angle is subtended towards the major arc and the other angle is subtended towards the minor arc. These two angles are related and angle C plus angle D is always 180 degree. ABCD is a cyclic quadrilateral in this case. ACBD is a cyclic quadrilateral because its vertices are on the circumference. So the sum of opposite angles of a cyclic quadrilateral is always 180 degree. Now next point. These two angles are also related. The angle subtended by a chord at the center is double the angle subtended by it at the circumference. Let AB and CD are two chords. One chord is closer to the center than the other. Then the angle subtended by these two chords at the center if we measure these angles, if we draw a circle and measure these angles, then we get that angle COD is always larger than AOB. So the angle subtended by the chord which is closer to the center is always greater than the angle subtended by another chord which is at a larger distance than the first chord. So angle COD is always greater than angle AOB. If we take two chords which are equal in length and which are at equal distances from the center, will subtend equal angles at the center. Okay. If we inscribe a square inside a circle, then the angles subtended at the center by the sides of the square will be equal, and each of them will be equal to 90 degree. This is a square inscribed in a circle which has equal sides. Okay, so they will inscribe 90-degree angle. They will subtend 90-degree angle at the center. In a circle, chords of equal length cut off arcs of equal lengths and produce equal subtended angles at the center. So for example, if CD and AB, these two chords are equal, then they will subtend equal angles at the center, and they will cut the arcs of equal length. That means arc CD arc will be equal to AB arc. Okay. If we draw two or more circles of equal radius and a chord which subtend let us say this is chord AB, this is CD, this is EF. They all subtend equal angles at the center. Okay, so circle 1, 2 and 3 are congruent because because their radii are equal. These three circles are equal. Okay, now if we take three chords A, B, C, D and E, F, which subtend equal angles at the center, then we can say these chords are also equal. Okay, circle 1, circle 2, circle 3 are congruent. Why? Because they have equal radius, and similarly they have subtended equal angle at the center. So we can say these these three chords will be equal. That means AB equal to CD equal to EF. Sorry, three collinear points. No circles can be drawn through three collinear points. Collinear means the points situated on the same straight line. Now our theorem 31, which says only one circle can be drawn through three non-collinear points. Only one circle can be drawn through three non-collinear points. We have to prove it. Now let us assume and we have to prove only one circle can be drawn through three non-collinear points. ABC are non-collinear. Now construction. We are joining AB and CD. I am not writing these points. You do it yourself. Construction. AB and BC are joined. Now we are drawing two perpendicular bisectors. The perpendicular bisector which bisects AB like this, and a perpendicular bisector which bisects BC like this. Okay, so this is our first perpendicular bisector and this is our second perpendicular bisector. Let us assume that the first bisector is PQ this is PQ and this is RS. The second one is RS. Now these two bisectors cut AB and BC into AB and BC at D and E respectively. This is point D and this is E. I hope it is clear to you. Now these two perpendicular bisectors will meet at a point. As AB and BC are not parallel, they will definitely meet at a point, intersect at a point. Let the point be O. Now we are joining OA, OB and OC. Okay, so this is our construction part. Now let us prove. Let us prove. Proof. For triangle AOD, this is D, this is O. AD equal to DB because PQ is a perpendicular bisector. That means it bisected AB. Okay, so this part is equal to this part. Okay, these two are perpendicular bisectors. So first AD equal to DB. Number 2, angle ADO equal to angle BDO. which is equal to 90 degree. Number 3, OD common side. Now from these 3 points we can say, therefore angle AOD must be congruent, triangle AOD must be congruent to triangle BOD. Side angle side congruency. Now if AOD and BOD are congruent, then we can say definitely AO equal to BO. Similarly, triangle OBE congruent to triangle OCE. Therefore OB equal to OC. So from these two conclusions we can say OA equal to OB equal to OC. Therefore if a circle is drawn with its center O and radius OA, it will pass through A, B and C. Therefore, only one circle can be drawn through three non-collinear points. Therefore, only one circle can be drawn through uh, three non-collinear points. I hope this is clear to you. Now you can add one or two lines, some extra informations that The 3 points A, B, C are fixed. Therefore, AB and BC line will be fixed. AB and BC will be fixed. The perpendicular bisectors of two line segment AB and BC are the straight lines PQ and RS respectively. Uh, Therefore, PQ and RS are also fixed. So their point of intersection O will be fixed. Again, since the 2 points O and A are fixed, so the length of the line segment OA is fixed. Therefore, only one circle can be drawn by taking the fixed point O at the center with a fixed length of radius. Therefore, only one circle can be drawn through three non-collinear points. You can add this information for accuracy. Now, let us do one application. This is application 2. It says, I prove with reason that the vertices of an isosceles trapezium are concyclic. So we have to prove it. So isosceles trapezium. Okay, let us first draw it. Sorry, the diagram is not proper. Okay, this is our isosceles trapezium. That means, okay, the non-parallel sides are equal. Isosceles trapezium means a trapezium in which its non-parallel sides are equal. Now, DC parallel to AC, sorry, AB. Now, you can write it properly. That means this is given to prove the vertices of an isosceles trapezium are concyclic. We have to prove that. Construction. Let us draw a perpendicular bisector of the side DC. This is our perpendicular bisector. Let us call it PQ. And another perpendicular bisector on the side AD. Let us name it RS. And they are intersecting at the point O. I hope you are able to understand it. Now, so first of all, we are drawing two perpendicular bisectors, PQ and RS, which are intersecting at a point O. The perpendicular bisector PQ cuts this side at point X and this side at a point Y. Similarly, this perpendicular bisector cuts this side at a point Z. This point is not needed, that is why XYZ is sufficient. XYZ are sufficient. Okay, we are not taking this point. Now we are doing one thing, we are joining AX and BX. Okay, see carefully. We are joining AX and BX. Okay, so first step, drawing perpendicular bisectors. Second step, joining AX and BX. Third step, now we are joining the points OD, OC, OA and OB with a dotted line, with dotted lines. Okay, done. Now proof. First of all, let us take two triangles. In triangle ADX and triangle BCX. Number 1, dx equal to xc, because this is a perpendicular bisector. PQ is the perpendicular, this is the short form of perpendicular bisector. PQ is perpendicular bisector of DC. Number 2, AD equal to BC, because this is an isosceles trapezium. Number 3, angle ADX equal to angle BCX, because an isosceles triangle. In an isosceles triangle, we know the angles associated with a side of the two parallel sides. Okay, these are two parallel sides, so the angle associated with any one of them are equal. So from these 3 points we can write, therefore triangle ADX congruent to triangle BCX. Side angle side congruency. Now therefore we can say AX must be equal to BX. Why? Because corresponding part of congruent triangles, CPCT in short. Now in triangles, in triangle AYX and triangle BYX, number 1, AX equal to BX, which we have proved just now. Angle AYX equal to angle BYX equal to 90 degree, and XY is a common side. Therefore, triangle AYX congruent to triangle BYX. RHS congruency. Therefore, we can say AY will be equal to BY. Why? Because corresponding parts of congruent triangles. So AY equal to BY. This is what we are getting. Now from this information we can say, therefore PQ is perpendicular bisector of AB also. Okay. Now, and O is situated on the perpendicular bisector. PQ of side DC. Therefore, please write down this information properly and draw the diagram. If this part is completed, we are going to proceed to our next part. Okay, from this information we can write, since O is situated on the perpendicular bisector PQ, we can write, see, for these 3 points C, D and A, in this case DC and AD are two lines and C, D and A are three non-collinear points obviously. So if we draw two perpendicular bisectors and they intersect at a point O, and if we join this point O to OC, we are joining OC, OD and OA. So we can say, therefore OC equal to OD, we are taking the concept from our previous theorem. Theorem 31. When two perpendicular bisectors meet at a point and we join that point of intersection to the points C, D and A, they will be equidistant from O. So OC equal to OD and OD equal to OA. Therefore, OC equal to OD equal to OA. Similarly, for these 3 points, point D, A and B, okay, we are taking 3 points, point D, point A and point B. For these 3 points, these are two perpendicular bisectors again, and they are intersecting at a point O. So D, A and B will be equidistant from this point O. Similarly, we can say and OA equal to OB. Okay, DO equal to OA and OA equal to OB. Therefore, DO equal to OA equal to OB. So from these two informations we can write, therefore finally we can write OA equal to OB equal to OC equal to OD. Therefore, by taking C as center with the radius equal to the length of, let us say, OA, if we draw a circle, then it will pass through the points ABCD. Okay, therefore now let us proceed to our next page. Therefore, with center O and radius OA slash OB slash OC slash OD, any one of them. If we draw a circle with center O and radius any one of them, then that will pass through A, B, C, D. Therefore, the vertices of an isosceles trapezium, therefore the vertices of an isosceles trapezium are concyclic. I hope it is clear to you and you are able to understand it properly. Now, if we draw a circle, let us say taking the radius OA, it will pass through all these points. Okay, I hope this question is clear to you. That's all for today. Tomorrow we shall come with another beautiful video where we shall be discussing the next part of this chapter. we are going to discuss about some more theorems, and after that we are going to start chapter 3.2. If you have any doubt or any question, if you have any suggestion, please leave that below in the comment section. Please help and support me by liking, sharing and subscribing to my channel. Thank you friends.